Can you explain SQL as well? Amar, you should have told me ahead of time because I don't have content for SQL prepared. Generally, what I do is I already prepare the tutorial content for you guys, and that's where we start from. But what I can do is I can make sure that we incorporate it in the next tutorial, inshallah. बल्कि next time इसके लिए we can maybe conduct a poll or something. All right, on that note, can you guys see my screen now? Okay, Amar, अगर आपकी अपनी कोई queries हो with respect to SQL, you are welcome to bring them up after we're done with today's content. All right, so let's get started. So first we're going to look at normalization. Now the thing is कि आप लोगों को normalization का with respect to the library sklearn code as it is याद नहीं होना चाहिए. It will not be tested. However, you should know this and it's going to help you in your project deliverable as well, the one that's due right after this. So, what exactly is normalization? This content was covered in class, but it's been a while. So, what we're doing here is essentially we're scaling our features to make sure that they range from 0 to 1 only. And why is this so important? For instance, if I show you guys something, this is the data frame that I've created. It contains two columns, namely age and income, and we have five entries over here. So why can I not use these values just the way that they are? Where exactly does normalization come in? Why must they be within the range of 0 to 1? So the reason for that is that basically when you're going to feed these columns, this data to your machine learning model, you don't want one feature to dominate over the others just because it has its values in maybe a longer range or generally they're bigger than the others. For instance, age is generally, or for that matter, mostly always in our data set, it's within the range of 25 to 45, just two-digit numbers. But income starts at a minimum of 50,000 and goes up to 100,000. If we were to feed data like this to any machine learning model, then the column income would perhaps dominate over the column age. But we don't want that to happen. We want equal representation for these when they're going into your model. So before modeling data, we use standardization or normalization, one of the techniques to ensure that they are within a certain range so that no extreme features are dominating over the others. All right. So one way of doing this is simply normalization, which ensures that our values are within the range of 0 to 1, and this is the formula used for it, which was also discussed in class. So for each point in your data set, such that each point is considered to be x, you take x and, well, you take the minimum value of that particular column. For instance, if I was doing this for age, I would take the minimum age and I would take the maximum age, and for each data point that I have in the column title age, I will subtract the minimum value from the point and then I will divide it by the range of values, which is just the max age minus the min age. That will give me the normalized value for age, and that will always be between 0 and 1. The closer it is to 1, the higher the age was, and vice versa. So it's a very simple formula. It's also very easy to implement it in code. We're going to try that right now. So normalization is also often referred to as min-max scaling. Yes, Hamza, go ahead. Hamza, आप please mic on कर लें अपना. It's showing something like data set. Hold on, let me look into that. Maybe I shared the wrong tab. All right, can you guys see the code on my screen now? Okay, all right, perfect, perfect. Moving on. So anyway, we haven't looked at anything particular in code yet. Just this formula for normalization. All right. So x minus min x divided by max x minus min x. Exactly what we discussed right now. So for a simple problem, we were just about to try it out. This is the data frame that I've created where the minimum age is 25, the maximum age is 45, the minimum income is 50,000, and the maximum income is 100,000. So normalization is also referred to as min-max scaling. Okay, I think we can implement this very simply in code without using any library right now. So I will do this. Min age equals df age dot min. I think everyone should be familiar with this simple aggregation operator. Let's see what we have obtained in min age as well. 25. Okay. So just like that, we would want to obtain the maximum age as well. Max age equals and then dot max. All right. And I think that's all we needed to do. Now I'm going to introduce a new column. Let's call it normalized age equals df age minus min age, okay, which we've already stored in a variable, divided by max, oh, max age minus min age. So we've exactly very simply implemented the formula that we see over here. And just like that, we can do the exact same operation for our other column as well. So let's see. Income and maximum income. We can very easily update this code over here as well. Yeah, here we have minimum income and income and then normalized income. Okay, now let's take a look at the data frame that we obtain as a result of this operation. All right, so this is what we have. Now, as you can see, if we just observe this over here for a minute, so you have your column of age and then you have a new column, normalized age, which is only ranging from 0 to 1, where the maximum age is represented by 1 and the minimum age is represented by 0. Everything else lies in between those two. Similarly, we have one for normalized income where the minimum income is represented by 0 and the maximum income is represented by -1. All right, so we're going to look at how you can do this for a more complex data frame. Now let's automate this process. We have a library for it. It's called sklearn. You will be using this for your projects, I believe. ठीक है, so from sklearn.preprocessing, you import the min-max scalar. This is the data frame that we will be using, and I believe I've shown you guys this data frame already. Life expectancy data, we have worked with this in our last tutorial as well. ठीक है, here you have 21 columns and, well, let's see how many rows we had. Okay, let's give it a second. We have an internet issue. ठीक है, here we go. We have 2,938 rows across 21 columns. First, what you would want to do is you would want to extract values from the life expectancy column. So this is the life expectancy column. On this column, we want to apply min-max scaling or what we call simple normalization. ठीक है? So for this, you have life expectancy data. Then you specify the attribute name, then dot values. And this is what we obtain as a result. a simple list of values. ठीक है, and then you have scalar dot min max scalar that we will be using. I have added this already for our ease. So life expectancy data, life expectancy equals, you don't have to add a new column to this any longer. Scalar dot fit transform is the built-in function that we use for transformations, and then inside fit transform you specify simply a series, which is in this case life expectancy data and life expectancy column for the data. Eventually we have, I can actually get rid of this thing for now either. So basically what we're doing is हम इसकी values को access करें just like we did over here because we want a list, and then we are reshaping these values, and we don't need to get into too much depth over here, but I will tell you guys why this reshaping is necessary. -1 specifies, basically initially you have your row number. -1 is not a valid row number, but essentially what it's telling our function is to make sure that it uses whatever number of rows we have by default, and then 1 is for your column because we only have one column. So after this operation, if we look at life expectancy data dot head, I think that should be about it. That should do our job. All right, it's between 0 and 1 now, and we can use precisely this operation for any other column for that matter as well. Let's look at standardization now, and how exactly is standardization different from normalization. So we're going to do a very quick overview of this because we've already covered this in class. So this is z-score normalization. Why we use standardization instead of normalization? Well, this technique is a little bit more robust to outliers than normalization is. ठीक है, and how is it more robust to outliers? As was discussed in class, यहाँ पे we take the mean and the standard deviation instead of directly taking the minimum and the maximum. अगर आप सिर्फ minimum और maximum लेते हैं तो normalization में what happens is कि जो आपकी extreme values होती हैं, they are very close to 1 or they're very close to 0, and that essentially disrupts the entire distribution. Because let's suppose the values of ages are like 10, 15, 20, 25, 30, and then due to an anomaly, there's an age that is 500. Now we know that's not valid. Maybe someone had to write 50 and they did that by accident when creating the data frame. So in order to avoid those problems, उसकी वजह से हमारी पूरी distribution disrupt हो जाएगी. Only that value will be very close to 1, and all the other values will just be kind of like clustered together. So that's why we rely on standardization, which uses the mean and the standard deviation. So for each data point, the z-score is equal to, or the standardized value is equal to that point minus the mean of that particular attribute divided by the standard deviation. Now, what happens to your data frame or to exactly your column after standardization is कि आपकी जो सारी values आती हैं as a result, their mean is 0 and their standard deviation is 1. This is how your data is distributed. So we have the same example over here. You have the exact same data sets. We're going to perform standardization. For this we need the mean and the standard deviation. I have already added the code for that purpose over here, and we've applied the formula. अच्छा, इसकी जगह standardize लिख लेना चाहिए. But I guess for now, let's just look at what output we obtain as a result. So normalized age equals df age minus mean age divided by standard deviation age. And then we do the exact same thing for normalized income. Now, if you look at your data frame, this is what it looks like. So now if I take the mean of the normalized age column, the mean will essentially always be equal to 0. If I take the standard deviation of this column, it will always be equal to 1.